Now we are going to say about Spark architecture. Spark architecture, we know that Apache Spark is a computational framework, but for data storage it is another one again. Actually, it is very good with Hadoop compatible data storage mediums like HDFS, HBase, Cassandra. And we can also store in S3 Amazon. So for data storage, if you use any one of these one, and Spark is only the computational framework. And for resource manager, it has its own standalone servers. For cluster management, it has its own standalone servers. Apart from this, it can also work with the Apache Yarn and the Apache Mesos. When it is working with the Apache Yarn and Apache Mesos, it can have additional capability like dynamic partitioning. And in case of RPI, API, it provides Scala, Java, and Python RPIs. The Scala language, actually the Apache Spark is 75% of the Apache Spark is developed with the Scala language. So developer can use the Scala API to develop Spark applications, or Java API to develop Java Spark application. So the API, I mean the Spark provides 3 APIs for the developers to develop Spark applications. Then I have already told you that the RDD, Resilient Distributed Dataset, is the core concept behind the Spark. That is, we can think of RDD as a table in database, and it is stored across the cluster as partitions. It can store any kind of data. So, and we can operate two kind of operations on RDD. RDD suppose two kinds of operations. One is called a transformation and another one is called a action. When an RDD, there is an RDD, when you operate a transformation operation, it returns a new RDD. It is original RDD, a new RDD will be written by the transformation operations. When you apply an action operation, it returns value. It doesn't return any RDD, it returns value. So when you apply a transformation operations, it returns a new RDD. When you apply an operation of action, it returns values. So and the examples of transformation operations are map, flat map, filter, group by key, reduce by key, etc. A number of operations are available for transformations. And for action, we have count, collect, first, take, for each, and other operations are also available for actions. So here we need to understand whether the RDD is mutable or immutable. Obviously, RDD is immutable. Why? Because it's dealing with the history data, it is immutable. So when we talk about whether RDD is mutable or immutable, RDD is immutable. But one thing we can keep in mind is when there is an external, the data stored in external systems or existing RDD, when you apply a transformation operation, it produces a new RDD with the transformation operations applied on the original RDD, and it happens in seconds or in few minutes. Because of that, it is assumed. We can assume that the RDD is also mutable, because the mutable, the process applied on the original RDD and the result RDD is available in immediate time. We can operate on this RDD immediately, so we can think it of as mutable, even though it is not immutable. We can treat it as if mutable. Both are available. Original and the new RDD both are available. We can operate on the new RDD immediately. So by which we can have some kind of mutable capability also with the help of Spark. Then we are going to these Spark features. There are three kinds of features. There are the three features we are discussing now. One is faster, another one is lazy evaluation. The third one is works both in memory and on disk. For faster, we know that because Spark is working in memory, I mean it stores the data in the memory of the clusters across the cluster server. It is very fast. I mean it is faster than any other big data technology. It is 100 times faster if it is only working with the memory. It is up to 100 times faster when it is working only with the memory. Even though it is working with the disk, it has got a time up to 10 times faster than any other big data analysis technology. So it is so faster than any other big data analysis. Lazy evaluation. It is one of the important characteristics of Spark. Let us assume there is a system data stored in external system, and we apply a transformation operation. Then it produces an RDD 1, that is assume. Then we are applying another one transformation operation. It produces a entirely new RDD 2, and we apply another one transformation operation. It produces entirely new RDD, let us assume it is 3. Then we apply an action operation, then it produces the result. So what do you think when you apply a transformation operation on the external system? The Spark will immediately produce this RDD, and when you apply another one transformation operation on this existing RDD, it produces a next RDD immediately? No. When you apply any operation of transformation, the Spark does nothing. It observes what is the transformation operation you are doing. It doesn't do anything. And when you are applying another one transformation operation, it does nothing. Until you are applying any operation of action, Spark does nothing. When you are applying an operation of action, then it analyzes all the transformation operations. It analyzes and evaluates and comes with the optimized way of processing the data. The transformation operations can be optimized so that the performance would be good. Performance would be optimized, and it will be executed in stages. Stages we will see in the later part. So once you are applying the operation of action, then only the transformation operations are evaluated and analyzed. This kind of characterization is called the lazy evaluation. And lazy evaluation, by which Spark provides high performance, because the data processing is optimized in a better way and it provides an high performance. And the third features we are going to talk about is works both in memory and on disk. Okay, let us assume we have already discussed a number of times that Spark stores data in the Spark stores the resultant data set in the memory of clusters across the clusters. I mean the memory of cluster is effectively used for storing the resultant data set. Okay, let us assume if the data set is too much to fit in the memory of the clusters, what happens? Do you think Spark gets failed? No. Spark is an execution engine. It is designed in a way that it can work both in memory as well as on disk. So what happens if the data set is too much? It stores part of the data in the memory and the remaining data is stored in the disk by which it is operating. Thank you. Then let us see in my next presentation for Apache components. Thank you.